Question number 15 says solve the polynomial by factoring. It might be hard to do, but we'll try it so that you can see how I would do this. So if I set it up like this, inside of this, remember how we did this before? So I'm going to multiply those. So 5 times negative 56, negative 280. So I need to find out what multiplies to be negative 280 and combines to be negative 27. So I'm going to go back to my calculator and go negative 280 divided by x. And the bigger number in the middle was negative. So I want to find my bigger number to be negative. So I'm going to go second graph. It's got to combine to be 27. 2 and negative 140. That doesn't. That doesn't. That doesn't. That doesn't. That one does. 8 and negative 35. So 8 and negative 35 combine to be negative 27. So I can put those in here. 8x, negative 35x. So this way they're divisible by 5. This way that's only divisible by 8. And then that's a negative 7. So 5x plus 8 and x minus 7. Again, a lot of you would like to just guess and check, and that works wonderfully on this problem, like 5. The only things that multiply to be 5 are 5 and 1, so I put 5 and 1 in here. And then multiplies to be 56 is 8 and 7. So I know that 5 times something is going to be my biggest number, so I make that one negative and that one positive. And then I normally do this in my head. I go 5 times 8 is 40, minus 7 would be 33, so that doesn't work. 5 times 7 is 35, minus 8 is 27. Okay, so that goes like that. So that's how I do it when I do it in my head. But anyways, now that you've got it factored, you can put each factor equal to 0. I just add the 7 over, so x equals 7. Now I go minus 8, minus 8. So 5x equals negative 8, divide it by 5, and x equals a negative 8/5. So if you wanted to type that in your calculator, you'd get negative 1.6. So on this one, since it's a polynomial, since it's a leading coefficient of 1, I'm just going to do this. The bigger number is positive, one's negative and one's positive, because it has to multiply being negative on the end. So multiplies be 63 is 9 times 7. Bigger number positive. 9 minus 7 is 2, so that works. Plus 9 minus 7. So x plus 9 equals 0. X minus 7 equals 0. So x equals negative 9 and x equals 7. So there we go. Again, you could have taken these to Desmos 5x squared minus 27x. 5x squared minus 27x minus 56. So negative 1.6 and 7. So negative 1.6 and 7. So just another way to do it. Pretty quick on Desmos. So as long as wherever you're at allows you to use Desmos, it's a great way to go. The ACT doesn't let you do it, but you don't have questions like this on the ACT. Number 17 says identify all the real roots of the equation. So if I come to Desmos, I've got that one typed in there. See how it doesn't ever cross the x-axis? There are not any real roots. So no real roots. If I were to use the quadratic formula, so negative b plus or minus b squared, the square root of b squared minus 4acl over 2a, and I plug stuff in, negative b plus or minus b squared minus 4ac all over 2a. When I do this part in here, I get 4 minus 4 times 2 is 8, times 5 is 40. So I end up with 2 plus or minus the square root of negative 36 over 4. Okay, the square root of 36 does come out, but that's an I, and we aren't after i's because we only want the real roots, not the complex ones. So no real roots. So you don't need to do what I just did with the square root and quadratic formula and that. I just wanted to show you how that looks because someday we're going to delve into this and do a little bit more. So now the next one, x cubed plus 3x squared minus 16x minus 48. So that's that one. So it crosses right here, -4, -3, and 4. So -4, -3, and 4. So how many real roots does it have? It has 3 real roots. What are the real roots? They're that. The other way to do this, it seems like maybe I'm wrong, but I taught you how to factor by grouping. I can't remember. Where you look at the first two and you look at the last two. These first two are divisible by x squared. That's x plus 3. These two are each divisible by -16. And if I pull the 16 out, that's left with x. 48 divided by -16 is 3. Now I set each of these equal to 0, or factor the x plus 3 out, sorry. I take out the x plus 3 from each of these, x plus 3, and then the leftovers go in their own parentheses. And so then I put each of those equal to 0. Sorry, I was jumping ahead. So x equals -3, and x squared equals 16, because I'd add 16 to each side. Now to get rid of the squared, I square root it. So x equals plus or minus 4. Okay. So now to the next one. How many real roots does that one have? Let's not use that one. Let's use this one. It has 1 real root, and it's at 5. Okay. So 1 real. What is it? X equals 5. So here's how this one would work if I did factor by grouping. I take the x squared out, and I get x minus 5. I take the 16 out, and I get x minus 5. 80 divided by 16 is 5. Now I take out the x minus 5 from each of those. And x squared plus 16 goes in its own parenthesis. And now I put those each equal to 0. But when I put x squared plus 16 equals to 0, and I minus the 16, I get x squared equals a -16. When I take the square root, I get a negative under there, which means I have a complex solution. So x would equal plus or minus 4i. But those are not real. So the only real solutions that we're after are these ones. These are complex solutions, which later on we'll work with, but for now, you don't need to. So some of you are like, well, why did you just do it? I don't know. I got carried away. Number 20, a children's game where you launch a frog by jumping on a container with an air hose attached to the frog base, launches the frog into the air. The frog's height versus time model is modeled by this equation. Factor the equation completely and then solve for t. Okay, let's do that first. So -8, oh, that's supposed to be a t on both of those. Sorry. If that's the only mistake, I'd be pretty happy. I'm sure there's some more, but anyways, there's one of them. Each of these are divisible by -2 and a t. So -8 divided by -2 is 4. I pulled out a t. 18 divided by -2 is -9. So I'm going to say -2t equals 0, and 4t minus 9 equals 0. So now I add the 9 over. So 4t equals 9. Divide it by 4. So t equals 9/4. Divide this one by -2. And t equals 0. So we solve for t. Time is 9/4 or 2.25 seconds. Or 0, that's when that thing's on ground level. So it looks like this. That's when it crosses the x-axis. Okay, if I were to come here, -8x squared, doesn't look like I have it on here. So I come down here, -8x squared, where'd it go? Plus 18x. Plus 18x. So see, that's the path of this frog, the height of this frog in relation to time. So the height goes up as time goes on. It hits a maximum up here, and then it comes back down, and there it is. So anyways, I gotta stop saying anyways. There we go. Now factor the equation, completely solve for t. We did that. What is the maximum height, and when does it happen? Well, it happens at half of 2.25. So 2.25, get out of there. Come on, calculator. 2.25 divided by 2. So it happens at 1.125. Much easier to see on our graph. There it is. And the maximum height is 2.125. So 10.125. And it doesn't say whether this is in meters or in feet. So we just have to put it's 10.125 units, whatever that is. The other way I could have found that is if I would have plugged in. So I have -8, 1.125 squared plus 18 times 1.125. So I could have just plugged once I figured out what the time was, when I took it and divided it by 2, I could plug that back into this equation, and that will also tell me the maximum height. So it says number 21, using a calculator, determine the amount of time it will take for a ball whose height is modeled by this equation. -10x squared minus 64x plus 4. So I come to Desmos, turn that one off. -10x squared minus 64x plus 4. That doesn't cross the 92-foot marker unless we're in negative time. I think that's supposed to be plus. That's better. So anyways, when you go to work on that one, make sure you change that to a plus 64x. Otherwise, you'll have problems. Okay, so that's number 21. Make sure we change that to a plus. 21, change to a plus. That's me making a note. Sorry, I should have turned the video off while I did that. Now I just come back to my calculator. We're supposed to figure out when it crosses the 92-foot marker. An easy way to do this is if I just go y equals 92, it's going to show me 45, 50, 65, 70, 92. There's a marker. So it crosses at 2 and 92 and at 4.4. So that's an easy way to find that on your calculator. Just say y equals 92, and there's the 92 mark, and then these x's are the time that it takes to cross that. So at 2 seconds and 4.4 seconds. It says to check your work with the quadratic formula. A would equal -10, B would equal 64, and C equals 4. So the formula is -b plus or minus the square root of b squared minus 4ac all over 2a. -b, so -64, plus or minus b squared, so that's 64 squared, minus 4a is -10, c is 4, all over 2a, which is -10. So I come to my calculator. I type a parenthesis. I go -64, make sure you use the negative, not the minus, plus the square root, 64 squared, minus 4 times a was -10, times c, which was 4, go out of my square root, close my parentheses, divided by parentheses, 2 times -10. Close my parenthesis, hit enter. Uh-oh. Something's not good. Error syntax. Go to. Enter. Oh. 2 times -10. Enter. So it says something wasn't good there either. Oh, I know what we did wrong. Remember I was supposed to say when does it cross the 92-foot marker, so there's supposed to be 92 equals. And then I minus the 92 and minus the 92 over here. So that should really be -88. So where this 4 is should really be a -88. So let's come back to my calculator. Let's go second enter. That's going to pull it back up again. And where this 4 is, come back. Whoa. 1, 2, 3, right there. We're going to make that a negative, and then I'm going to go second, insert, 88. No, not there. Second, insert, parentheses, negative. The calculator does exactly what you tell it to do. Sometimes I tell it to do things that I don't want it to do. Especially with this keyboard, I hit the wrong button sometimes. Now let's try that. Oh, there we go, 2. Now let's hit second enter. Second back over here. Now I minus, change that, and 4.4. Now those match up with what we had on our calculator, on our graph, 2 and 4.4. So there we checked it with the quadratic formula after I remembered what I needed to do correctly. So we had to change that h of t to be 92 because we wanted it to pass the 92-foot marker. So that was the height. So we had to figure out what the time was to get the height of 92. Question number 22. Determine if these are inverses of each other. Remember, to determine if they're inverses of each other, you're going to do f of g of x and g of f of x, or fog, or goff, depending on which way you like to see that. But I'm going to take g, and I'm going to plug that in for that x right there. So I have 2x plus 5 minus 5. So I distribute that 2, I get 4x plus 10 minus 5, I get 4x plus 5. That did not make just plain old x. So as soon as I find out on one of them, it didn't work, I'm done. So here's what the real inverse should have been. Remember that we have y and that's x, and we swap those, so x equals 2y minus 5. So I should have added the 5. So x plus 5 equals 2y, and then you would divide it by 2. So x plus 5 all divided by 2 is what should have been over here if they are indeed inverses of each other. But they weren't, so it wasn't this, so they weren't inverses. But this is how I want you to show that they are inverses. Question number 23, show if these are inverses. So let's have our fog. So I'm going to take this whole thing. I'm going to need that later. And I'm going to plug it in for that x right there. So I'm going to have 5 parentheses 3x squared plus 4 all over 5. Close my parentheses, all over 3, all under the square root. And then out here we're going to have minus 4. Wowzers. That's a mess. Well, these 5's go away, and I am left with 3x squared plus 4 all over 3 in here under the square root. Well, this 3 will go with that 3. But remember what it really is it looks like this. So yeah, that 3 cancels that one, and that leaves me with x squared. But then it leaves a mess right here, because that doesn't come out nice and pretty. And so are these inverses? No. So if we were to find the inverse, we would have y equals the square root of 5x plus 2 all over 3 minus 4. If we were to find this inverse, we'd swap x and y. I would add the 4. So x plus 4 equals the square root of 5 parentheses y plus 2 over 3. Now to get rid of the square root, so I'd square that. So I'd have x plus 4 quantity squared equals 5 parentheses y plus 2 over 3. Then I'd get rid of that divide by 3, so I'd multiply everything by 3. So now I have this. So now I would get rid of that times by 5, so I divide everything by 5. So now we have 3 times the quantity of x plus 4 squared, all divided by 5, equals y plus 2. So my last step would be to minus that 2 away. So 3x plus 4 quantity squared all over 5 minus 2 equals y. That's what the inverse should have been. So this is what should have been here. So the only thing wrong with this, realistically, is it should have been x plus 4 quantity squared in here. But that does make it so they are not inverses of each other. So you've done your job as soon as you found, no, you didn't need to do all of this. That's just me going crazy for some weird reason. I don't know what happened to me, but I did it. Now it says using the given function, create the inverse function. So that's what I was just showing you how to do. So let's do it now that we're supposed to. So y equals 3x minus 7. So let's swap those two, x and y. So x equals 3y minus 7. So now I add the 7 to each side. So I have x plus 7 equals 3y. So now to get that y all by his lonesome, we divide everything by 3. So y equals x plus 7 over 3. Our final step really should be to change that y out to f negative 1. That just means this is the inverse of f. If I were to do function composition and plug these two together, it would just give me back to x. They would undo what each other are doing. Okay. Now on this one, that's a y, so let's replace those. So that's x equals 4 parentheses y minus 2 squared plus 3. So we've done the first step. We've swapped the x and y's. Now we have to do all the tedious solving for y. So I minus the 3 from each side. So I have x minus 3 equals 4 parentheses y minus 2 quantity squared. I'm going to get rid of that times by 4, so I divide everything by 4. Now what we have is x minus 3 all over 4 equals y minus 2 quantity squared. So we need to get rid of that squared, so I square root everything. So x minus 3 over 4 square root equals y minus 2. So now I'm going to add the 2 over here. So y equals x minus 3 over 4 plus 2. That's under the square root. And that's my inverse. Okay. Because I didn't really specify whether I'm using only half of this, we should probably put plus and minus on here. And I went a little far with that line. Come on, eraser. There we go. Plus 2. Okay, I really should have said x is greater than or equal to 0, and we'd only use the positive case. Or if I would have said x is less than or equal to 0, we'd have only used the negative case. But I didn't specify that on this, so you'd have to put plus or minus just to say we don't know which way you were thinking. On this, we change that to a y. Now I swap my x and y's. So x equals 3 square root of 2 parentheses y minus 4 all over 5. Add the 7. So I'm going to minus the 7 from each side. So I have x minus 7 equals 3 square roots of 2 parentheses y minus 4 all over 5. So I'm going to get rid of this times by 3 on the outside. That means I divide everything by 3. I have x minus 7 all over 3 equals the square root of 2y minus 4 all over 5. So to get rid of the square root, we are going to square everything. So I square that side, I square that side. So I now have x minus 7 over 3, all quantities squared, equals 2 parentheses y minus 4 over 5. So now I need to get rid of this 5. Normally I'd really do both of these at the same time. So I'm going to. I multiply by 5 halves, and that way the 5 cancels out that 5, and that 2 cancels out that. And what I do to that side, I do to this side. Is one side I do to the other. I now have 5 halves. X minus 7, whoops. X minus 7 quantities over 3 divided by x minus 7 divided by 3 squared equals y minus 4. So my last step on this wonderful, beautiful mess is add 4. What I do to one side, I would do to the other side. So I have 5 halves times x minus 7 divided by 3 quantity squared plus 4. And that's my inverse. What a mess. And since this was the positive case, x would be greater than or equal to 0 on that. So that's the beautiful mess on that. Not really beautiful, but a lot of steps, pretty complex, but I think you can do it if you'll tackle them one step at a time. For some reason, I wanted to throw this problem on. I don't know where it came from in my head, but I was just thinking about it and wrote it down. So here you go. A jumping fish reaches a height h above the water at any given time, modeled by this equation. How long is the fish in the air? I realize that if I just say this is 7 and that's 21, they're each divisible by negative 0.7. So I take that out, and I would get a problem that looks like this. So that's factoring out a negative 0.7. So now that I've got it factored, oh, that's supposed to be a squared on that problem. Now that I've got it factored, I put each of those equal to 0. So the fish leaves the water at times 0, and it flies through the air for 3 seconds. It's quite the amazing fish. So how long is the fish in the air? It's in the air for 3 seconds. What is the realistic domain? Anywhere from 0 to 3 seconds on this. And what is the range? Well, we don't know yet, but we're going to figure it out. The range is how high it goes. So it's going to be anywhere from 0 to that maximum height. So we're going to plug 3 in for that x. So I have negative 0.73 squared. Whoa. Plus 0.21 times 3. No, not 0.21. 2.1. There. And it says it's 0, which it should be because we know that's when it comes back down to the ground. So if I hit second enter, remember I was supposed to have typed in 1.5 because that's the halfway time. So let's replace those 3's with 1.5's, and that's going to be the maximum height. So I hit 1, and then I'm going to hit second insert, 0.5. Things look good. So that fish goes up there 1.575 feet, meters, whatever our units are. Miles? No, not really. So whatever our units are, that's how high our fish goes. It's probably closer to, I don't know, meters would be pretty high. That's probably more realistic. And that finishes things up. So that's the pre-test. Good luck with that. And hopefully that helps you do well on the test.